Hello. Our group is Lockheed Martin number one, and for our capstone this year, we worked on the Everglades Wargame.
All right, let's do a quick introduction of Lockheed Martin. So Lockheed Martin is our sponsor for the project, for our capstone project, and we're given to do a AI war game. So where we're using different reinforcement learning. So quick background on Lockheed Martin as a company. Lockheed Martin is a aerospace and defense company. It's one of the largest contractor for the U.S. federal government. They have throughout the years, they're making a huge advancements. They primarily sell to the U.S. Departments of Defense, U.S. Department of Energy, and NASA. So Lockheed want us to do a turn-based strategy video game. So it's played by people, not autonomous software. So it's played by not people, but by autonomous software. So Lockheed goal for us is to develop further advancement in reinforcement learning for coders and gamers.
So our project was developed entirely on the Everglades Wargame platform. And what this is a 1v1 strategy game designed entirely just for training these AI agents. So what this game consists of is a map for units to play on, and then also three types of combat units with different amounts of speed and damage and health. And so you can see in this image on the right that there are two bases, the blue base and the red base, and then also the 9 white neutral territories in the middle. And those neutral territories exist for either team to go and capture them. There's also something called the fog of war, which means that players actually aren't allowed to see like the movement of units and what's happening on each of the territories unless they captured that territory or they have units on top of it. And finally, there are 3 win conditions for the game. The first of which is the first player to capture the enemy base. The second of which is whichever player has the highest score after 150 turns. And the third of which is the first player to eliminate all the enemy units. They will win after 150 turns is reached. And as to why we're developing on this project, there are a couple different reasons. So Lockheed Martin wants to develop their skills with AI, machine learning, and reinforcement learning. And this platform lets you train a whole bunch of things on that and figure out what you're kind of doing with regards to reinforcement learning and learn a lot of new things. They also want to develop partnerships with universities and students and potentially hire talent that performs really well at the game. And the third reason is they want further adoption of the Everglades wargame by both Lockheed employees and non-Lockheed employees. So basically, like university students, people like us.
Reinforcement learning is an area of machine learning concerned with how agents, which we can think of as players, decide to take actions in an environment, which is usually a game, and that's in order to maximize some sort of reward. The reward is usually winning the game. Basically, the way that it works is that environments give the agent the current state, which is where everything is in the game, and then a reward, which is whether or not the game's been won. Agents then return by giving the environment an action, which is, for example, if it was chess, it would be which piece moved where. And the goal of reinforcement learning agents is to choose the best action to maximize the reward. And different reinforcement learning agents use different strategies and different training, which we'll talk about later, to decide on what is the best move.
The first reinforcement learning algorithm we decided to go with was PPO, which stands for Proximal Policy Optimization. An easy way to think about this is you have a gradient, let's call it a mountain, and you sample around yourself to find the steepest incline because you know that's the fastest route to the top of the mountain. If you do this enough times, you're assured to find the top of the mountain. We chose this algorithm because it's very easy to implement, and it's proven in numerous studies to get excellent results competing with even the most complex algorithms.
So DQN stands for Deep Networks. It's one of the agents that we use. We use PPO, ACC, and DQN. DQN is one of the next we use. It's a pretty good, reliable agent. So basically, a DQN agent is a value-based reinforcement learning agent that trains the critic to estimate the return or future rewards. So a little bit about the experience replay is that basically, there's different data collected after each step of the agent, right? So there's going to be data collected after each step of the agent. And for the replay memory, so basically a replay memory is mainly used to train the DQN by getting a random sample of replays and use those replays as input of the DQN. And the reason why with DQN we're using random sample of replays instead of sequential replays is that, using sequential replays, the DQN tends to overfit instead of generalization, right? Generalizing. So using sequential replays, the DQN tends to overfit instead of generalizing. And with DQN, it was a good, we chose DQN because it was a pretty solid agent to use, and we were just super passionate about the agent, and it was something that we really liked. And that's why we plugged that and tried to get it as maximum possible in terms of the win rate. And it was a great experience with DQN.
The third agent we worked on used the A3C algorithm. A3C stands for Asynchronous Advantage Actor Critic. An asynchronous implementation brings the advantage of having a global network that controls multiple agents. You can see a representation of this architecture in the figure on the right. Each agent's learned knowledge contributes back to the total knowledge of the entire system. This makes the A3C implementation faster at learning than other standard reinforcement learning techniques and results in a better performance. The advantage metric below, where V is the expected value at the state S and Q is the resulting value for the action A taken in the state S, tells the agent how actions rewards compare to what it expected as a reward. This is how the agent learns what actions will lead to better results.
Hi, I'm Desmond. So for this project, we measured our success kind of by looking at two different metrics. So the first is we measure our success by looking at our agent win percentage against a random agent. So what that looked like is we took the agents we created and we put them inside of the Everglades Wargame, tuned the hyperparameters, and then ran them against a random agent many, many times over. And then from there, we looked at our average win percentage against a random agent. So for our implementations, our PPO implementation was working with a 73% win rate, which we were really happy with. Our A3C implementation, we have a completed gym setup, gym implementation, but it's not quite at the point of being able to compete against a random agent, and that's also true for our DQN. So by looking at win percentage of agents, we have one agent working with a high 73% win rate, which we're really happy with. The second metric we kind of looked at is kind of our growth as a team. So here, we definitely all grew in our understanding of what it takes to bring a project like this from start to finish and all the different components that go into that. You don't really see it from, you think about it from the outside, which is really cool. I'm really happy with. I think we all definitely also improved in our knowledge of deep learning and what these implementations look like and what they take, which we're happy with. And we worked really well together. So overall, we're really happy with this project and how it went.
With regard to technical skills, our group went into this project with very little experience in reinforcement learning. So we learned a lot about how we can implement reinforcement learning algorithms and how to tune hyperparameters to improve an agent's game performance. We also learned a lot about how to manage a year-long project by breaking it down into many smaller, more attainable goals that are measurable, and by making sure to have deadlines to help us hold ourselves accountable and stay on track. And lastly, we learned how to be an effective group despite being entirely remote by having good communication and by using collaborative approaches like pair programming to work together. For many of us, this was our first time working in a group of people that we had never met in person, and I think that we had a lot of success.
And that concludes our capstone project. Thank you for listening.